Hello everyone, this is the complete P4 lesson. P4 lesson, this series will contain all the step-by-step explanations of each chapter of the Pure Mathematics 4 of the Edexcel International A-Levels Mathematics. So let us start with chapter number 2. Chapter number 2 is partial fractions. In partial fractions, we will talk about three types of fractions. Number 1, n means numerator and d means the power of the denominator. So n means the power of numerator, d means the maximum power or the index of the denominator. So in the first type of the math, the numerator power, the numerator index, the maximum numerator power will be less than the denominator. In the second type, the numerator power will be equal to the denominator power, and in the third type, the numerator power will be greater than the denominator power. So the first one is a proper fraction. This is a proper fraction, and the second and third are improper fractions. So I will not go into details about the definitions or dictate them to you because these are not necessary for our exams. What's necessary is how to convert the fractions into partial fractions. So we will straight go into that. First of all, type 1, that is where we have the numerator power less than the denominator power. So what do we mean by the numerator power less than the denominator power? So let us talk about a bit. Let us talk a bit about index. Index means, for example, we have this equation x square minus 2. This expression has an index of 2 because the maximum x power is 2. 2 minus 3 x to the power 5. This one has an index of 5 because the maximum power is 5. Even if you add something here, cube, the index still remains 5 because the maximum power is 5. However, if you add something like this, x to the power 7, then the index becomes 7. The maximum power is the index. So there are three types: the numerator index less than, the denominator equal to or greater than. So we will move on to the first type where the numerator index is less than the denominator index. So number 1, numerator index less than the denominator index. That is type number 1. I will mostly work with the examples in the book, but I will explain them how they came about so that you can understand the concepts. And if there are any particular maths that you want me to explain, you can comment on the video and then I can explain those particular maths to you just before your exam. I'm planning to make another video where I will just explain the math that you have requested me to solve. So for now, I'm just giving a general explanation of how to convert the fractions into partial fractions. So the example that I'll be solving now is example number 1 from page number 7. This is the book that I'll be following, P4. So from page number 7, I have example number 1. So page 7, example number 1. The math that I have here is 6x minus 2 divided by x minus 3 x plus 1. Right. So I have to convert this into partial fractions. In order to convert this type of expression into partial fraction, what we have to do is this. We have two factors per se in the denominator. Okay. So these factors we have to separate by fractions. Two factors, so two fractions. In the first fraction, I'll have one factor. In the second fraction, I will have the second factor. Now, we don't know what to put in the numerators, so we will put a and b. Okay. Now we know how to take LCM of the fractions, so we will take that LCM, that is x minus 3. We are no longer working with this. We have totally forgotten this part. Now we are working with only this part. Only concentrate on this part. So we will convert this thing into one single fraction by taking LCM. So x minus 3 and x plus 1. And if you divide this entire denominator by this denominator, we have x plus 1 left. Once again, when you divide this whole thing by this, you have x plus 1 remaining, just like a numerical LCM. So we multiply a with this remaining, that is x plus 1. Now, when you divide this whole thing by x plus 1, this denominator, we have x minus 3 remaining. So we will multiply b with that remaining part, that is x minus 3, just like a numerical LCM. Now what we have to do is, we have this expression here, we have this expression here. So let me just write this thing over here once again, the same thing. just for the sake of easier comparison. I'm writing it down again. Okay, observe the denominator is same in both cases, only the numerator is different. So can we say that the numerator is equal to this numerator, like this? 6x minus 2 equals a x plus 1 plus b x minus 3. I'm very much sorry for my handwriting because what I'm typing is not being exactly replicated on the board. There is being a slight distortion. As you can see, when I write something, it takes a different shape immediately. So in order to find the value of a, we have to vanish b. We somehow have to get rid of b. So how to get rid of b? If you multiply b with 0, then the whole b vanishes. Anything into 0 is 0. So if you can multiply b by 0, the whole b will vanish. With b we have x minus 3. Somehow if you can convert this factor into 0, then b can be multiplied by 0 and the whole thing, the b, x minus 3 will disappear. That is why we are taking x equal to 3, because from here we can see if the value of x is taken as 3, this whole thing will become 0, b into 0 will become 0 and we will have only a left. So when we take x equal to 3, what happens? 6, we are taking x equal to 3 for the whole expression, by the way. So 6, 3 minus 2 equals a 3 plus 1 plus b 3 minus 3. Okay, so 3 minus 3 is 0. So anything into 0 is 0. So the whole thing becomes 0. So we have 6, 3 is 18 minus 2, that is 16 equals 4a plus 0. This whole thing becomes 0. So from here we can see the value of a turns out to be 4. Yes, the value of a is 4. Similarly, if we want to vanish a, then we have to take the value of x as minus 1. So 6 into minus 1 minus 2 equals a minus 1 plus 1 plus b minus 1 minus 3. From there we can have the value of b as 2. Okay, so this was pretty straightforward. It's not necessary for you to always take x equal to minus 1 in the second part, because notice that once you know the value of a, you can put any value of x that you want, except for 3, of course, any value of x that you want, and you can find the value of b. So it's not necessary for you to vanish a, since now we know the value of a. So in our book, basically they have used simultaneous equations by taking two random values of x. You can do that as well. But if you can take a value of x and directly get the value of a or b, then it is better to do that. It will save you some time. In example number 2, they have done the same thing, but here what they have done is they have put 3 factors in the denominator. If there are 3 factors, you will take 3 fractions. In this example, we had 2 factors, so we took 2 fractions. If there are, for example, 10 factors, you will take 10 fractions. No problem with that. So if there are 100 factors, you take 100 fractions, no problem. So the number of fractions will be equal to the number of factors that we have in the denominator of the main fraction, the question fraction. Now, one variation of this question could be, this might not always be in factorized form. The question could tell you to convert this into partial fractions, something like this, x square minus 5x plus 6. They could tell you to convert this into partial fractions. There is nothing to get scared. You will just have to convert this into the factorized form. You can use your calculator, or you can do middle term factorization, or use the quadratic formula, and you can convert this into the factors, x minus 2, x minus 3. From there we will proceed like this. So this was one of the types, and this was type 1. We'll move on to the second type. Okay, so before moving on to the second type, we have one more variation of this type. The variation will be something like this. The variation is when we have repeated factors. The book section number 2.2 is repeated factors. Repeated factors means, for example, you have something like this. We have example number 3, we are talking about 11x square plus 14x plus 5, the whole thing divided by x plus 1 whole square 2x plus 1. So we have to convert these into partial fractions. So the only difference with the previous part is that we have to take all the powers of x plus 1, something like this. So we have x plus 1 whole square, we have this. Now we also have to take a lower power of x plus 1 until we reach the power of 1. We have already reached 1, so we stop here. And we take 2x plus 1. And here we have a, b, and c. So let me show you another example. For instance, if this power was not 2, if this power was something like this, if this power was 4, for instance, so I would have taken 4 power, then x plus 1 to the power 3 plus x plus 1, the whole thing to the power 2 plus x plus 1, the whole thing to the power 1. I will stop when the power is 1. So here we have b, we have c, we have d, and for 2x plus 1 we have just one single power, that is 1. So we just take it as it is. I will not go into the detailed solving of all the examples so as to save you some time. I will just give you the basic concepts, and there will not be any conceptual gap, but I will not solve all of the math just to save your time so that the video is not too long for you. So moving on to the next type. So exercise number 2b deals with this type of math where you have repeated factors. So now you should be able to do exercise 2a and 2b of P4. Now, moving on to the second and third type, improper fractions. Moving on to the second type and third type, improper fractions. So improper fractions have one common instruction, that is we have to do this long division. So this long division process is not shown here, but I will show you some way of long division by which you can solve this math. So for instance, example number 4. Let me work with example number 4 and show you how long division can help us in this case. Before that, we have to understand what is our quotient, remainder, and divisor. So when you have something like this, you are dividing 7 by 2. You are dividing 7 by 2. So can I write this like this? You are dividing 7 by 2. This can be written like this. Okay. So dividing 7 by 2, we have 3, we have 6 here, and 1. We are no longer, 1 is no longer divisible by 2, so we end here. Here, our quotient is 3, our remainder is 1, and our divisor is 2. Our divisor is 2. Can we write this fraction like this? 7 by 2 can be written like this: 3 plus 1 by 2. Okay. Basically, 3 whole 1 by 2 is exactly the same as 3 plus 1 by 2. So we can write this 7 by 2. We can write this 7 by 2 as 3 plus 1 by 2. What is 3? 3 was our quotient. Our 1 was our remainder, and 2 was divisor. My point is that when we divide a numerator by a denominator, and when we do the long division, we can write the fraction like this. We can write, for example, you have the numerator here, the denominator here. After doing the long division, when you have this quotient, divisor, and remainder, you can write something like this: quotient plus remainder by divisor. Okay. So what this will do is, this will save you some time of working with the index. For example, if you don't do this long division, the method shown in the book shows that you have to understand what is the index of the numerator and what is the index of the denominator. And after judging that, you have to write the fraction in a plus b by your factor, or ax plus b plus c by your factor. So whether to write the quotient as a linear term, or a quadratic term, or a cubic term will depend on your judgment of the numerator and the denominator. So if you have done a basic reading of the chapter, starting from section 2.3, example number 4, 5, and so on, you can understand that you have to go through this judgment. But the method that I'm showing you now does not require that judgment. Whatever improper fraction that you have, be that numerator power be equal to denominator power, or numerator power be greater than denominator power, whatever improper fraction you have, you do the long division and then follow this method here. Let me just make this better. You have to follow this format here, that your fraction, the question fraction, can be written as quotient plus remainder by divisor. You follow this and then you break this one into partial fractions. Break this one into partial fractions and you will be done. You will be done with your answer. So let me just give you an example. We will be working with example number 4 and we will see how this method brings us to the same solution as the book. Okay. So for your note, it is necessary for you to only understand this part, to only take note of this part. Okay. For the total understanding, it's recommended that you copy the entire thing, but for doing the math, only this part is enough. Just before going to the exam, only this part is enough, that you see the fraction, do the long division, and after that you have this format and convert this R by D into partial fraction. So I'll be erasing the board now. Okay, so we have 2x divided by x plus 1. This is our main fraction. This is our main fraction, numerator by denominator. So can we write this like this? We can write it like this, right? So how to divide 2x by x plus 1? We need 2x at the bottom, but we have x here. How to convert x into 2x? We multiply this thing by 2. Okay, once again we have to multiply our divisor by something so that we have 2x at the bottom. So what do we multiply with x plus 1 to get 2x? We multiply 2. So 2 into x plus 1, that is 2x plus 2. Now we know what to do. The signs change like this. 2x cancel out and we have minus 2 over here. Okay, so this was our main fraction, right? This is our main fraction which we did the long division. Now we can write this like this. This is our quotient. Our quotient is 2. You are encouraged to write it like this in the exam as well, so that you don't mix up. This is your remainder and this x plus 1 is your divisor. So we know that the fraction can be written as quotient plus remainder by divisor, right? Our quotient is 2 plus our remainder is minus 2 and our divisor is x plus 1. Okay, we have our answer. If you bring this minus over here, minus into plus is minus, so minus 2 by x plus 1. Here we have our fraction. So our fraction can be written like this, x plus 1. Okay, so when the math is simple like this one over here, it may seem that both the methods take the same time, or maybe the method shown in the book might take lesser time for you, although it has 2 variables here and we don't have any variable over here. But as the math gets complex, more and more complex, this method will save you a lot of time. If you have improper fraction, do the long division, follow the quotient plus remainder by divisor rule, and then convert this one into partial fraction. So something interesting here to note that this is already a proper fraction. So this is already into one single fraction. So we don't have to convert it into partial fractions. This already has one single factor, so we don't have to convert it into partial fractions. But if for example, if it had another factor like this, x minus 2, then we would have needed to convert this into partial fractions as well. Partial fraction as well. So let me see if there are examples which shows this. Okay, I think we have something. Let me see. So we are moving on to example number 5 now. We're doing example number 5 of the book, which has something like this: 3x cube divided by x minus 1, x minus 1 and x minus 2. So first of all, what we have to do is, since we have to do the long division, we can't divide by x minus 1, x minus 2. We have to convert this into one single expression. So 3x cube, we have x square minus 3x plus 2. Okay, plus 2. Okay, we have it. So we convert, now we do long division on this fraction, not on this fraction. Long division over here. So x square minus 3x x square minus 3x plus 2 divides 3x cube. For beginners, or if you are a bit uncomfortable with the long division, I recommend you to do this: 3x cube plus 0x square plus 0x plus 0. So this makes you a bit more comfortable. Okay. This is especially useful when we have, suppose, 3x square minus 2. 3x square minus 2 and the middle terms are missing. Then we can substitute the coefficients by 0 so that we have 3, all the coefficients, x cube, x square, x, then 0, or x to the power 5, 4, 3, 2, 1, 0. That makes our long division a bit more comfortable for us. So what do we have to multiply with this expression? What do we have to multiply by with this expression to get 3x cube? We already have x square. If we multiply 3x, we get 3x cube. Don't worry about the remaining part. Only worry about the first part of here and first part of this and the first part of this one over here. So we have to multiply something by x square so that we get 3x cube. That thing is 3x. So 3x cube minus 9x square plus 6x. Okay, so change the signs like this, and like this. So 3x cube minus 3x cube cancel out. 0 plus 9x square is 9x square, and 0 minus 6x is 6x, and we have plus 0 over here. Okay, now what do we have to multiply with x square to get 9x square? 9 plus 9, positive 9. So we have positive 9x square minus 3 9 is 27x plus 18. Okay, dividing the whole thing, we have minus here, plus here, minus here. So we cut this thing. 27 minus 6, that gives us 21 minus 18. Okay, so now the index of this expression 21x minus 18, the index is 1 and the index of the divisor is 2. Whenever the index of what we have over here becomes less than the index of the divisor, we stop our long division. We can no longer proceed. So now we stop our long division. We can no longer proceed. We already have our quotient, that is 3x plus 9. We have our quotient. We have our remainder, and we have a divisor. Okay, we have a divisor. Now what we do is, we write our fraction in this form: quotient plus remainder by divisor. Our quotient is 3x plus 9. Okay, our remainder is 21x minus 18, and our divisor is x square minus 3x plus 2. X square minus 3x plus 2. Okay. You might think that this took a lot of time, but if you become fluent with the long division, this will save you some time, and most importantly, you don't have to remember or go into the depth of understanding the index and when to put what expression just by looking at the fraction. You can apply just one single method. This method might seem a bit lengthy, but it is applicable in all types of improper fractions. So what we have to do next is, we have to convert this into the factors. We have to convert this into the factors, because we don't have to convert a fraction when the denominator has only one factor. But we can clearly see that the denominator over here will contain two factors because it's a quadratic expression. And we have just seen that this comes from two factors. So our two factors go like this. From here, our two factors are x minus 1 and x minus 2. X minus 1 and x minus 2. These are our two factors. Now we convert this thing into partial fraction. So I'll be erasing this part over here so that I can do the rest of the working. If you want, you can take a screenshot or a note of this part. Right, moving on. So we convert this part into partial fraction only this part. How to do that? We have 21x minus 18, and we have x minus 1. and x minus 2. Okay, so we have x minus 1 here plus x minus 2 here, and we have a here and b here, right? So taking LCM, x minus 1 of this part, x minus 1, x minus 2. Now this has converted to type number 1. This is now type number 1. So we have this here, a into x minus 2 plus b into x minus 1. So the type that now I'm showing you, x minus 1. The type that now I'm showing you is both type 2 and type 3. Both are covered in this part. Okay. So now we can convert the numerator with the numerator over here, because the denominators are now same, x minus 1, x minus 2, x minus 1 and x minus 2. The denominators are same, so we can we can compare the numerators like this. 21x minus 18 equals a x minus 2 plus b x minus 1. Now, in order to find the values of a and b, what we have to do is, in order to find the value of a, we have to vanish b. How to do that? If you multiply b by 0, the b vanishes. How to multiply b by 0? By converting x minus 1 into 0. How will x minus 1 be converted to 0? By taking the value of x as 1, because 1 minus 1 is 0. Okay. Now, what to do if this factor is a bit complex? Then how will you understand what to put the value of x? You simply do this. Put x minus 1 equals 0. That gives you what? That gives you x equal to 1. With this means that if you put the value of x as 1, this whole thing will become 0. This is what you should do when this factor is a bit complex. So x minus 1 will be converted to 0 with the value of x as 1. So taking x equal to 1, taking the value of x as 1. So 21 into 1 minus 18 equals a 1 minus 2 plus b into 1 minus 1. Okay, from there we have, let me write it at the bottom. 21 minus 18, that gives us 3. A 1 minus 2 is minus a, and this whole thing becomes 0. From there we have a equals minus 3. A equals minus 3. Similarly, let me just erase this part over here, or rather this part. Okay, now continuation from here to here. Similarly, when we take the value of x as, now what should I take the value of x to vanish a? 2. So the value of x will be now 2. 21 into 2 minus 18 equals a 2 minus 2 plus b 2 minus 1. Okay, so 21, that is 42, minus 18, so 42 minus 18, 24. We have 24 here, and a becomes 0 and b becomes only b. Okay, so this is b. Now we know both the values of a and the value of b. So this fraction can be written like this: 3x plus 9 plus 21x minus 18, the whole thing divided by, oh, we have already written this part. We have broken it into partial fractions, so let us write that form. This fraction can be written in this form. So a by x minus 1, what is a? A is minus 3. So minus 3 by x minus 1 plus b by x minus 2. b is what? 24. 24 by x minus 2. So now you will notice that ax plus b. So let us see if we match with the answer in the book. Ax plus b. The value of our a is 3. The value of a is 3. And in the book, the value of a is, okay, once again in the book, the value of a is 3. It is not specifically stated, but it is 3. You can see in a side note on page number 13. The value of b is 9, so that matches. Above x minus 1, we have c. So the c should be minus 3 in the book. Yes, c is minus 3. And d, we have 24. That matches with the book as well. So our answer matches with the book. So this is particularly useful This is particularly useful when there are a lot of other variables, a, b, c, d, e, f, many variables, and this method is useful particularly for that reason, because you don't have to judge what to put, what will be the general format of your partial fraction, because here the first line of the question is the fraction has been written as ax plus b plus c by x minus 1 plus d by x minus 2. So how should you know what will be the general format of your fraction? You can understand if you follow the lesson in the book, but the method that I've shown you will apply to all the improper fractions, that is both type 2 and type 3. Now you should be able to do number 2c and chapter review number 2. If you have any confusion with a particular math in this chapter, please let me know in the comment section, then I can make another video where I will explain those particular maths only. Thank you very much for watching this video, and I hope that I will get you with me in the next video as well.